Hi everyone, we're going to be talking about a new topic today called trig equations. Now in the past, we've looked really extensively at trig identities. Identities are equations that hold true for all values of the angles, or at least nearly all values of the angles. Occasionally there's a couple you may not be able to include, but generally speaking, identities hold true for all angles. Trig equations are those that hold true for only a few particular values of angles. Okay, so it's not going to be all of them, it's only going to be a handful, and we have to solve for those handful of angles. Now, to solve equations, there's a variety of things we've done in the past. You learned these in your algebra classes, and so they shouldn't be new. I'm just going to review a few things for you before we get into the trig equations. Okay, so the first thing, really all of your properties or principles of equality, right? Your addition principle, your subtraction, multiplication, division, all these things. So basically, you know that if you add something to one side of an equation, you have to add the same thing to the other side, right? Or subtract from, subtract the same amount from both sides, or multiply or divide. And so those are going to be important as we move forward. So I'll put that up on the list here. So one of our tools, basically I'm just kind of writing out a toolbox. We're going to go to work with a toolbox, certain things in our toolbox, and then we're going to use those tools to solve these equations. Okay, so the ones that are important for us here are principles of equality. And when I say the principles of equality, just know those are the addition principle, multiplication principle. You can, whatever you do to one side of the equation, you have to do to the other side of the equation there. We also have something called the square root property, right? Square root property. Some people call this taking the square root of both sides, although that's kind of technically not what you're actually doing. The square root property is, if you had something like x squared equals 9, then x is equal to plus or minus the square root of that 9, or 3, right? And so the square root property says if you have x squared equals a number, then x is the positive or negative square root of that number. Okay. Again, some people say, well, you're just taking the square root of both sides, which you kind of are, but because of the plus or minus in there, it's a little bit of a tweak. So we're just going to call it the square root property. Okay, so here in this case you'd have plus or minus 3 as your answers. Okay, so the square root property is going to be important here. We also have another property called the zero product property. This one's going to become very important as we move forward. The zero product property is one where basically it says that if you have two things multiplied together that equals 0, then it's necessary that at least one of those two things is itself 0. Okay, so then A equals 0, B equals 0, or both. All right, that is the zero product property, and that occurs for not just two factors, but any number of factors, right? And you know that 0 times anything is 0, and anything times 0 is 0, and 0 times 0 is 0. But there's no way to possibly get two non-zero factors together and their product be 0. That doesn't work. Okay, so if a product is 0, at least one of the two factors, or three factors, however many you have, must be 0. Okay, and so you would apply this, generally speaking, in the cases of polynomials. When you have something like x squared plus 7x plus 10 equals 0, you would use the zero product property by factoring the polynomial into factors a and b, and then setting each one equal to 0, right? So x squared plus 7x plus 10. To factor this, you find factors of 10 that add up to 7, which are 2 and 5. So you'd have x plus 2 and x plus 5 equals 0, this is kind of like the A and this is kind of like the B, right? There's two things multiplied together. A times B equals 0 in the zero product property. Then either A equals 0 or B equals 0 or both, which we don't really have to worry about the both scenario. So we just say, well, the first one equals 0 or the second one equals 0. As long as one of those two is 0, then the whole thing is 0. Then you just finish that off with a -2, subtract your 2 and subtract your 5 from both sides. Okay? So this concept is going to be important. It's just going to look different when we get into the trig equations, because instead of having x's here, we'll have trig functions like secant squared plus 7 times the secant plus 10 or something like that. So we're just going to have to make some adjustments and kind of reorient how our brains think about these variables, right? So instead of having a variable, it's going to be a trig function that we're working with, all right? And along those lines then, you are going to have to be familiar with factoring. You're going to need to do factoring in order to do the zero product property or to apply that. You may also see some instances where the quadratic formula is utilized. Because the quadratic formula works to solve polynomial equations, or quadratic equations, when they're not factorable, right? Actually, it works for all of them, but it's especially helpful when it's not factorable because you can't use the zero product property, or at least you can't use it as easily, okay? So the quadratic formula, and of course, if you needed that, if you had the equation ax squared plus bx plus c equals 0, then the quadratic formula, hopefully you've seen this before or are familiar with it, is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Right? And we'll revisit it if we need it. I'm not sure that there's a lot of those, but it could occur. All right. Again, the weird thing about these is that instead of having an x as your variable, you might have a tangent of x or a tangent of theta, some trig function, in which case you'd have tangent of theta here equal to this stuff, figure out what this stuff is, and then you still have to solve for theta, so then you have to apply an inverse tangent, and so that's where this topic gets a little bit tricky, right? So you're building off of all these algebra skills and then applying some of our trig skills that we've been learning. I think this is the main outline of the tools that we need, right? This is our toolbox. There may be some other things, obviously things that we've learned in this class, like our identities, our Pythagorean identities, our quotient reciprocal identities, our cofunction identities. All of those could be very important. Our double angle, half angle, product to sum, sum to product, all those different identities that we've been studying the last few weeks are going to be also potentially important as we try to solve these trig equations, just trying to get the two sides of the equations to simplify so that we can really work with them easier, okay? Okay, so anyway, that's just kind of a rundown on some things that you're going to be able to utilize. And then the other really important thing is you got to know your inverse trig functions. If you do need to go to a calculator to get some values out, you've got to know what quadrants the calculator is going to be giving you angles for, because it may not be the quadrants you're looking for. And we've talked about this in the past, that the calculator has a restricted range for the inverse trig functions, and so we may have to alter that to get maybe a third quadrant angle or a fourth if it's not going to give us that. Okay, so you just got to be careful, what quadrant your solutions are in. You may also find that you need multiple angles. Maybe there are multiple angles or multiple quadrants in which the solution could occur. And so you just have to be aware of that and try to account for all of those little discrepancies. So solving trig equations is going to have a lot involved in it. It's not just a straightforward, here's my equation, I do this step, this step, this step, and I get an answer. There's some analysis involved in solving them. We'll go through some examples in the next few videos.